So I'd like to say one more thing about visiting comets. And a more recent visit to a comet was done by the Rosetta spacecraft. This is a European Space Agency spacecraft. And the idea was that it was going to have a mothership that would slowly approach a comet and go into orbit around the comet and study it over an extended period of time for months as it swept near the sun. And then a piece of it was going to detach and then land on the comet. So the lander was going to actually position itself on the surface of the comet and ride it past perihelion. And so this was a huge huge idea here that we could do this. And so it was all exciting. So the comet they picked was this comet right here. And I have trouble pronouncing that name. So a lot of people do too. It's a really long name, so a lot of people just call it Comet CG. Okay, and so this was Comet 67, Churyumov, Gerasimenko, Comet CG. And the spacecraft was launched in 2004 and was arrived at the comet August of 2014. The lander detached and tried to land on number 14. The mission lasted until the end of December of 2015, orbiting by the sun. And so the comet, as there was a starting approach, realized it's another one of these odd sort of things. It's like two things that are attached. And so that didn't seem to make sense. As it got closer, again, this is even weirder. Okay, you can see in the background some of these jets spewing out right here, but you have one nodule over here, you got another one over here, and they've made contact in the middle here. Again, this is kind of like these double asteroids. It is possible that what's happened here is you had a comet. Remember, these things are sometimes not well put together. So it got close to the sun, broke apart, and then two pieces drifted back together hard enough that they kind of merged or fused in there. And so, but then you look at it and say, well, where are all the craters? There don't seem to be any craters right here. Now, maybe in the shock of slamming back together, it partially melted, the insides rearranged, and so forth. The rock-ice mixture got rejumbled amongst itself, and you end up with this kind of like weird-looking thing right here. Okay. So what happened was that the lander detached and came in to land, and then bad things started happening. Okay, so what happened was this thing, kind of like the previous comet we talked about, Comet Borrelli, not Borrelli, but VO2. This comet is largely fluffy on the inside. A lot of empty space, so much less gravity than expected. So when the spacecraft landed, it touched and bounced, and then bounced, and then bounced, and then bounced, and ended up kind of laying on its side next to this cliff, which is miles high. And again, this thing is a very rough sort of structure right here. And you land next to that cliff right there, which jagged sort of structure that sticks up extremely tall. Okay, and now as this thing is spinning and rotating through space, then I guess the cliff's really about a half mile tall rather than a mile, but it's a tall cliff right there. And so what happens is that now our solar-powered lander is sitting in the shadow. So it pretty much lost power eventually and quit broadcasting. Every now and then, as it was passing real close to perihelion, the rotation of the comet wobbled enough that sunlight would hit the lander and it would momentarily be a little bit active and then die again. But up close, what we see here is once again a world that doesn't bear any resemblance to any other object in the solar system. So this comet, once again, is totally different from anything else that we expected. And so they're still working on this and trying to figure out, how it came to be this way. One thing that they found, though, was that this comet had isotope ratios here that in the water, because water's got hydrogen and oxygen. Some of that hydrogen is deuterium. Most of the oxygen is oxygen-16. Some is oxygen-15, which is also stable. The isotope ratios do not match the water we find on Earth. Okay, so some scientists came along and said, oh, well, since it doesn't match, that means that comets did not actually deliver the water to Earth. Okay, that's probably a premature statement because we haven't sampled other comets this closely. We have not checked isotope ratios of other comets, just this one. And we do know that different comets from different parts of the solar system are going to be different. So this could be a weird comet or this could be a normal comet. We don't really know. So the idea, your book also seems to indicate that that certainly comets like this were not the sort of comets that would have brought water to Earth. Okay. We're not really sure where Earth's water and carbon all came from. Turns out Earth has a lot more carbon in it than we originally suspected too. Much of the carbon deep in the interior of the Earth. That's not going to be brought to Earth necessarily by comets. Now, some carbon on Earth gets shoved down into the interior through plate tectonics. So there's a huge carbon cycle on Earth that does that. But there's too much carbon in there to be fully explained by surface carbon being shoved inwards, which means that some of the makeup of the Earth had carbon in it. And if it did, it almost certainly had water in it. So how watery the planetesimals were that made Earth, we don't know. How much the water at the surface was brought by comets, we don't know. So this is still an unanswered question. And we're still trying to figure this out. But unfortunately, this mission just raised more questions rather than answering them because we don't even know if the comet that we studied is a normal comet or of a weird comet. It certainly doesn't look like any of the other comets we looked at. So that does suggest that possibly this is not representative of other comets. As I said, the Philae Lander, which landed, did bounce a little bit and finally came to rest in the shadows, and so it really did not live up to expectations as we had hoped. Okay, so what do we get from our visits to comets? Well, every comet we've looked at, like every asteroid that we have looked at, seems to be unique. They're all different. Well, what does that mean? Well, we're still trying to figure that out. Does that mean every one of them is different, or there's different families of comets? Like there's different families of asteroids. Some of the asteroids look similar to other asteroids, so maybe there's like the general term we call asteroid might really represent several different types of objects. Likewise, the general term comet might really represent several different types of objects. Just because when it gets close to the sun, it develops a cloud and a tail, doesn't mean they're all just alike. And so the formation, they form in different places. Okay, between Saturn and Neptune, they form closer than that, maybe near Jupiter and Saturn. They form beyond Neptune. They get kicked outwards when Saturn and Jupiter move. They get kicked out when Uranus and Neptune move. We got Kuiper Belt comets, we got Oort cloud comets. Some of them may have formed before the solar system formed. Some of them may have formed in the propylid as the solar system was forming. Some of them may have formed after the other planets formed. And some of them may have been altered by successive passes and heating close to the sun, and others of them have not. So that means that all these comets seem to be very, very different kinds of objects. And therefore, we probably cannot say that we really know about comets yet. We know way more than we did. When I first started teaching astronomy, all we could say is that there's a solid nucleus in there somewhere. We're pretty sure, but we don't really know much more about it than that. We had the Whipple ideas as what it might be like, okay, but we weren't really sure. And then we have the coma, or the head of the comet. We got the tails. We were pretty sure what those were and how they worked. The hydrogen cloud of gas around it, we knew about that. And so all this seemed to make sense, but we still didn't know a whole lot of details about comets until we started getting spacecraft that could go look up close. And unfortunately, rather than answering all the questions, it answered a few of the questions and raised a whole bunch more questions for us to study.